to track the object via convolution in real time. In this lecture, we are going to track the object movement in every frame obtained from camera. We will run the code, detect and track the object from one frame to another, and visualize track a line. Pay attention, to implement this activity, you need to have a very simple background, like this one. If our background is complex, there will be a lot of different objects. In this case, to track the needed object, more advanced algorithm is needed. Anyway, we are going to implement a simple object tracking via 2D image convolution in real time to sense this operation and experience useful results. Hi everyone, my name is Valentin Sichkar. Let's get started. Learning objectives for this activity are as following. You will be able to implement 2D convolution by TensorFlow class and in real time. Detect the object and visualize tracker line. Show x and y coordinates of the tracked object. We will also experiment and apply 2D image convolution to track the object not only by camera, but additionally on video file. We will detect the object, draw bounding box with the label around this object, visualize track a line and x and y coordinates of the current object center. Let's begin. Here are two options. Clone or download the code file, or simply code while watching. Find the link in the description. Pause video and come back when you are ready. We will code in PyCharm. However, by the link you will find the code in Jupyter Notebook. Anyway, they are 99% the same. Let's jump to the programming environment. This is file track object via convolution in real-time Py, and we are going to implement 2D image convolution to detect and track object in real time. The code in this file is 90% the same as in previous lecture when we implemented convolution in real time. That's why we will quickly review it. Algorithm is as following. Firstly, we set up one-channeled Sobel filter for edge detection. Next, we prepare OpenCV windows to show results in. Then, we read frames one by one from camera, initialize 2D convolutional layer by the help of TensorFlow, and feed every captured frame into initialized 2D convolutional layer. On every output from 2D convolutional layer, we detect the biggest found contour and draw a bounding box with label around this biggest contour, but on original RGB frame. At the same time, we prepare tracker line. Finally, we cut detected object and show all results in separate OpenCV windows, including tracker line. We also calculate VPS rate used to process every single frames. As a result, we will get OpenCV windows that will show us 2D convolution to detect and track object in real time, object edges obtained by 2D convolution and Sobel filter, track a line with current x and y coordinates, and bounding box around object that will be identified by the help of found edge. Let's go through the code, but stop for more details only when there are differences from the previous lecture. Here we import minimum needed libraries. The difference is in this library. We import this DQ object in order to collect x and y coordinates of the tracker line. DQs are Python data type that represents generalization of stacks and queues, and it is very convenient to use it. We can dequeue and enqueue from both sides. We will consider it in a few moments. Find also more details by the link at the end of this code file. In the first block, there are additional settings that can be applied in case of CUDA and TensorFlow issues when GPU is used instead of CPU. The code is the same as in previous lecture. In the next block, we set up Sobel filter. The code is the same as in previous lecture. In this block, we initialize OpenCV windows. The difference is in the last window. We give it following name. In the next block, we start to read frames from camera. The new code line is here. We initialize DQ object specifying in the argument maxLen number of maximum points that can be stored in our DQ object. For example, when we collected 50 points coordinates, then next 51 coordinate will also be added, but the very first coordinate from the opposite side will be removed. Therefore, total number of coordinates will always be 50. We will see how it affects visualization of the tracker line in a few moments. Later, you can experiment and adjust this number for your own project. By the help of this while loop, we catch frames one by one from camera. The code is almost the same as in previous lecture. In this block, we get spatial dimensions of the frame for the first time when they are still none, and initialize 2D convolutional layer by TensorFlow for gray input and one-channeled Sobel filter. The code is the same as in previous lecture. Find detailed explanation and more examples of usage TensorFlow 2D convolutional layer class in the following lecture. In the next block, we implement 2D convolution to the currently caught frame. The code is the same as in previous lecture. In the next block, we find the biggest contour. The code is the same as in previous lecture. In the next block, we draw bounding box, label, and prepare tracker line. The code is almost the same as in previous lecture. The new code lines are here. We calculate current center coordinates of the bounding box, x and y, make them as integer numbers. Calculated center coordinates we enqueue to our DQ object from the left side. In the next block, we cut detected fragment from currently caught frame. The code is the same as in previous lecture. In this block, after we obtained the results, we show them in prepared OpenCV windows. The code is almost the same as in previous lecture. The new code lines are here. By the help of this for loop, we iterate all currently collected center coordinates inside our DQ object and visualize them. We start to visualize points only when there are at least 2 of them already been collected, and we check it by this condition. We also stop to visualize them when next points are not collected yet, and we check it by this condition. By the keyword continue, we go outside this for loop and proceed to the next code line. To draw a line between already collected center coordinates, we apply OpenCV function CV2 line passing as first argument prepared NumPy array with image, start point to draw the line, and end point. We also specify color of the line and its thickness. Later, you can experiment and change these arguments to find better options for your own project. To visualize x and y coordinates, we apply 2 times OpenCV function CV2 put text passing appropriate coordinates. Find explanation for the arguments in the previous lecture. After all needed information is added to the image, we show it in this OpenCV window. Every new frame, this information will be updated and typed again. In this block, we calculate VPS rate. The code is the same as in previous lecture. Finally, we break the while loop if letter Q is pressed. go outside the loop, release video capture object, and destroy all opened OpenCV windows. As usual, at the end you can find some useful comments. Join these lines before opening this link in browser window. It is separated here in order to fit the screen size. Let's run the code. We can see window with current view from camera and bounding box around biggest found contour. Next window with output from 2D convolution that shows us detected object edges. One more window with cut fragment that is object itself. And window that visualizes tracker line as well as x and y coordinates of the current object center. All windows are updated in real time. Pay attention on FPS rate. It depends on the capacity of machine you use. OK, let's press Q to stop the loop. OK, let's now apply 2D convolution, but now for video file. Uncomment this line of the code and comment this line. You can also change label here. Let's run the code. We can see window with bounding box around the biggest found contour, window with detected edges, window with cut fragment, and window with tracker line. As can be seen, the tracker line has specific length that is 50 points only, as we specified earlier when initialized the Q object. In this lecture, you obtained new skills. We successfully implemented 2D convolution in real time to a sequence of the frames obtained from camera. We polished already obtained skills from previous lecture. To visualize results, we showed separate OpenCV windows. You are able now to track the object via 2D image convolution, show tracker line, and represent current x and y coordinates of the object center. Code that we ran in this lecture you can modify and apply to your own project. Use this code as template, implement needed modifications, and apply it to any other project you have. Do you want to train Deep CNN model? Then join the course. Find the link below this video. You will be able to design your own Deep CNN model for classification tasks. Train and test this model on image and in real time by camera. Build your own classification report and analyze confusion matrix. Click the link below to start now. Thank you very much for watching. Please be sure to like this video and subscribe to the channel if you haven't already. See you soon in the next lectures.